today's topic is Laplace transform. From Laplace transform, today we are going to discuss partial fraction. Why partial fraction? In Laplace transform, many stages we need to find inverse Laplace of any functions, right? So in that case, we can use partial fraction. How? Many times in denominator you can find this kind of term, that is something upon s plus a s plus b, and we need to find inverse Laplace transform. Sometimes we need this kind of term, that is some function upon s plus 3 raised to 3 or s plus s minus 2 raised to 4, something like that. Or many times you can find this kind of term, that is 2s upon s square plus a square into s square plus b square. So total we bifurcated this fraction into three parts, that is linear and non-repeated, means linear terms, and distinct, that is s plus a, s plus b, s plus c, and so on. Second is linear and repeated, in that case s plus 3 raised to 2 or s plus 2 raised to 5, repeated powers like that. And third is quadratic terms, that is denominator contains some quadratic terms of s, right? In today's lecture we are going to discuss linear case 1, that is linear and non-repeated terms, and we are going to discuss two examples in that case. Whenever we have this kind of example, linear and non-repeated terms, we will write fs equal to some constant upon first factor, some constant upon another factor, and continue. Let us have first example. In this case, we are interested to find Laplace transform of this term, that is 1 upon s minus 2 upon s plus 1. So let us start. Here we have f of s equal to 1 upon s minus 2 s plus 1. We can see that this is the case 1. S has one power, that is linear, and both are different, that is non-repeated. So I will write first constant upon first factor and another constant b upon s plus 1. Now I will find a and b. Just take LCM and I will get this a into s plus 1 plus b into s minus 2. Now cross multiplication upon denominator has s minus 2 and s plus 1. Both side denominator is cancelled. So finally I will have this kind of term. Now as I am interested in finding a and b, I will take different values of s. So let us take s equal to minus 1, and on the other hand I will take s equal to 2. By taking this, I will have some values of a and b. Let us take check for minus 1. Left hand side minus 1, no need, that is 1 actually. Now minus 1 plus 1 0. First term 0 plus minus 1 minus 2, I will get minus 3b. So finally b equal to, I can write minus 1 by 3. Now let us put x equal to 2. Left hand side 1 as it is, equal to a, s equal to 2, that is 3, and second term is 0. So finally a equal to again 1 by 3. As I said, we are interested in these constants, and I am this constant. Now substitute this constant in this thing. Let us say it is 1. So from 1 or substituting in 1, I will get a upon s minus 2 s plus 1 is equal to a 1 by 3 upon s minus 2 as it is plus b, that is negative 1 by 3 upon s plus 1. What next? Just take inverse Laplace on both sides. So Laplace inverse of, that is our question, 1 upon s minus 2 s plus 1 is equal to, now this constant, as Laplace transform is linear transformation, I can write this thing, 1 upon s minus 2 minus 1 by 3 Laplace inverse of 1 upon s plus 1. 1 by 3 as it is. Now we know the Laplace inverse of this term, that is e raised to 2t, minus 1 by 3 as it is. Laplace inverse of this term, that is e raised to minus t. So finally my answer is 1 by 3 common, e raised to 2t minus e raised to minus t. That is the answer. That is actually the inverse Laplace transform of this function, right? Okay. So let us take next example, and that is we need to find Laplace inverse of 3s square plus 2 upon s plus 1, s plus 2, s plus 3. Three factors, and all three are different, distinct. So I will start with this thing. Let 3s upon s plus 1, s plus 2, s plus 3 equal to a upon s plus 1, another constant b upon s plus 2 plus another constant c upon s plus 3. By taking LCM, I can write 3s square plus 2 equal to a into s plus 2, s plus 3 plus b into s plus 1, s plus 3 plus c into s plus 1, s plus 2. This is just a simply LCM, nothing else, right? Again, we are interested in these three constants. How can we find? Just take different values of x and simplify it. So I will start with let us take s equal to first of all minus 2. S equal to minus 2. Next I will take s equal to minus 3, and next I will take s equal to minus 1. Okay. So s equal to minus 2 on left hand side, minus 2 square, 4 is at 12 plus 2, 14. Left hand side equal to 14, minus 2, 0 plus b into minus 2 plus 1, minus 1, minus 2 plus 3 plus 1. Last one is 0. So finally b equal to I am having minus 14. First constant is there. Next, let us take s equal to minus 3. Minus 3 square, 9, 9 is 27 plus 2, 29 is equal to minus 3. Minus 3 whole term is 0 plus b. Minus 3 plus 3 whole term is 0. So a first term 0, second term 0. Now c into minus 3 plus 1, minus 2, minus 3 plus 2, that is minus 1. That is c equal to, and this is positive, and finally I will have 29 by 2. That is another constant. Let us take s equal to minus 2. Sorry, minus 1. So minus 1 square, 1, 3, 3 is 1, 3 is 3 plus 2, 5 equal to a into minus 1 plus 2 plus 1, minus 1 plus 3, 2 plus minus 1, so this comes 0, again minus 1, this term is 0. So finally a equal to I have 5 by 2. Right? So now I have all these three constants in which we are interested. So let us substitute this in equation number 1. So I will write from 1 this term equal to, that is 3s square plus 2 upon s plus 1, s plus 2, s plus 3 equal to a upon, that is a upon s plus 1, that is 5 by 2 upon s plus 1 plus b, that is minus 14 upon s plus 2 plus c, that is 29 by 2 upon s plus 3. Now just take inverse Laplace on both sides, that is 3s square plus 2 upon s plus 1, s plus 2, s plus 3 equal to 5 by 2 outside, Laplace inverse of this 1 upon s plus 1, which gives me e raised to minus t. Again minus 14 outside, constant 1 upon s plus 2, that is e raised to minus 2t, and 29 by 2 common, 1 upon s plus 3, that is e raised to minus 3t. So this is my answer, e raised to minus t minus 14 e raised to minus 2t plus 29 by 2 e raised to minus 3t. That is the final answer, which is the inverse Laplace transform of this function. In today's lecture, we discuss only first case, which contains linear and non-repeating terms in denominator. In next lecture, we will discuss type number 2, that if the denominator has linear and repeated term. Thank you and Jai Hind.